All right, welcome back to another video of baremetal C. This is part 5 of the series. I can't believe we're already in the 5th video. This video is very important. We're actually going to be implementing UART or USART or, through serial communications. And we'll be doing that using the same circuit we made before. So this was where we left off last time. So I pressed the button, it stays on, I let go, stays off, and it works independently. So you see that LED just keeps blinking because we implemented Millis. Now, what I want to do in this video is that whenever I press this button, I wanted to print like a hello world, a message. So in the last video, this is where we left off. So we had a button where we pressed, it turned on an LED, and then it turned it off. And then we also had the blinking LED, which blinked independently from the blue LED. So in this video, we're actually going to focus on implementing the UART and interfacing with the different registers involved, how to pass character bytes, integers into the serial so we can actually get some value, right? We have to have a way of debugging and to see what is going on. This is especially useful when we start having sensors and different ADC values. We want to see the values actually being printed out. Okay, so the first thing you want to do is here we have our main, and you want to go on our left side and press new file and write uart.c. Now go back to the main and just grab these top 4 libraries and bring it to UART. And you need usually these 4 as your core on each source file. It's very important. So the first function we're going to make is our initialization function. A function that initializes anything that is such as a sensor or a protocol is required. And this function is usually called once at the beginning of your project in the main. So located here, like our system time initialization. Now the UART is slightly special because this initialization actually requires you to pass a value. In this case, a baud rate, just like you would in the Arduino. In the Arduino, you have something called serial.begin, and you pass a value such as this, okay? This value is your baud rate, and the function inside of serials class called begin will actually calculate different values to push onto different registers so that you actually have access to sending at this baud rate. So let's do that. Let's create void uart underscored init. And it's going to get an unsigned 32-bit integer called baud. Now, what do we do with baud? We have to actually calculate the baud rate register value, or UBRR value. So let's do that. UBRR underscore value is equal to a function to actually calculate this, right? How do you calculate this value? So what I'm going to do is I'm going to go to the datasheet. And here we have the datasheet for the serial communication protocols and different flags and different registers. So if my memory serves me right, the equation or the formula is here. So it's your frequency divided by 16 multiplied by your baud rate minus 1. So if we implement that, it looks something like this. Now to access the frequency of your microcontroller, you can actually just get it by doing f underscore CPU. Then we divided this by 16 and it's multiplied by the baud. And all of this subtracted by 1. Now, I recommend is putting in an unsigned long here so that since we're dividing by a very large value, it's always sometimes good practice to just have an unsigned long dividing that number, that integer. Okay. The next is we want to set the high byte and low byte of the baud rate register. Now, this is our value for the baud rate register. And to set the high byte and low byte, you do UBRR 0H, and H stands for high or high byte, and is equal to a casting call for an unsigned 8-bit integer, and it's going to be UBRR underscore value and the high 8 bytes. So these are the high byte. Okay, we're setting this value that we get from here, and we're setting into here. This is required based on the data sheet from the microcontroller. Now the low byte is the same thing, but you don't actually need to specify your push because it's just the low bytes. All right. So now that that's done, we actually need to enable our transmission to the serial port. To do that, we need to do an access UCSR 0B, and it's equal to this bit mask. So this is the transmission enable register. Now, where did I get this value from, right? Where did I get this register from? Well, first of all, I'm going to start from the high byte, low byte, and then here. So if I go here and I go down, we see that here there's a C code example which defines their baud rate value here, and they do the same thing that we did. Okay. And then they do this. Okay. So where did they get this from? So it's already, this is already an example code from the data sheet, but where they get it is that it's the name of that register, and the enable, transmission enable, is actually the bit number. So here we have UCSR B, and here we have bit number 3, which corresponds to TXEN. And TXEN, which is bit 3, means transmitter enable. Great. So I'm going to bring this to the side, and this means that it's TX enable. So what's our next line of code? What are we supposed to do here? So here we actually have to define our data format or data frame. And to do so, we actually require UCSR, but group C. And group C has these bits from 0 to 7, so 8 bits in total. And UCSZ number 1 and UCSZ 0, if we go lower, we see that it corresponds to the bit setting. And it specifically corresponds to the number of bits, the data bits. And we see that when these two are high, it corresponds to 8-bit data. Okay, so let's do that. Let's access UCSR 0C, and it's equal to 1 UC, and it was UCSZ 0. So UCSZ 0, and the first one we want to turn on is number 1. So I'll put number 1, and we're going to do an OR, and then do UCSZ 01. So I'm just going to make sure this is right. I made a typo. I forgot a C here. All right. So this allows, that's a 0. So this allows for 8 data bits to be transmitted. What about our stop bit, right? Because when you want to transmit data through a line, you have your start bits, your data bits, you have the stop bit, and also a parity bit in between. So if I go up here, I believe we passed it, if my memory serves me right. This diagram is actually really important. So you have your start bit, you have your data bit, which we just defined. So we have all of this. We have a parity bit, which we don't really need. And we have your stop bit. Now the stop bit by default is 1 because it's low. And if you go down, down to here, you see that USBS bit setting. So this is your stop bit. You see that 0 means 1. So you don't need to define it, so it's 1 by default. If your receiver is slower and requires you to have a longer delay between each data being transmitted, you can set it to 2-bit. That just requires you to put this register to high. Okay, so we are now done with the initialization. Great. So we did this, we enabled our transmitter and the data frame format. So what's next? Let's actually send a byte to our register that is in charge of transmitting data. So we're going to pass an 8-bit integer, and we're going to call it data. And in here, we're going to put a while loop. Okay. Now this function sends 1 byte over the UART. We first wait until the transmit buffer is empty by checking a specific register. And only when it's ready do we load our data into the transmission register. And that's what actually sends the byte. Okay. So to do that, we actually go in here and we write UCSR 0A. So this is our register, and the bit mask is this. Now, what is a bit mask? A bit mask is just a reference address you do so that you compare it with this. And this is bit number 5 of this register. And this does a bitwise AND operation with this register. Okay. If I go here and I do 0B 101 000 this is our UCS R0A. Okay, that's what this is. And when you do this, let's say that looks like something like this. Okay, but let's say like the first one is 0. Since it's bit number 5, so 0, 1, 2, 3, 4, 5. So this is the bit number 5. That's what this is, by the way. When you do an AND operation, you see that it's a non-zero value. And since it's a non-zero value, that means that it's ready to send. If it's 0, so if it's false, that means it's not ready to send. And we actually have to put a negation here to check whether or not it's true or false and do the opposite. So this will be in a loop whenever the transmission line is busy. Okay. If it's not busy, we do UDR 0 is equal to data. And that's it. We've just successfully sent a byte over to this register, the register in charge of transmitting that data to the serial monitor. Okay, so what about sending a string, right? This is just sending a single byte of data. So to send an actual string of data, we will just define it as print string. So it's easier to write whenever we want to write something to the serial monitor. And we pass a constant character so that we make sure it's not changed as a pointer called str. Now we do while, so we do a while loop, str, UART, send byte, str plus plus. So whenever you're passing, so when you call this function, it'll look like this. and you print, for example, hello world, this is a character. So that means that this is your pointer, because you're basically turning this into a pointer, and each of these letters will have a corresponding address. And this will dereference this. So it'll turn it back into your character, and it'll go one character at a time. Okay. So it'll go one character at a time. So it'll always increment by 1 whenever it's passed into here. Okay. So it will loop until there is no more characters. Okay. That's all that this is doing. This plus plus will just increment this, because the address for each of these will always be next to each other. So that's why this always holds true. So H will be, for example, address 0, E will be address 1, L will be address 2, and so on and so forth. And this will just increment that value, pass it over to this to then print it onto the UART. How about sending over an integer? Okay. Now to send over an integer, we're going to say print int, right? Print int. That kind of rhymes. That rhymes. And we're going to pass an 32-bit unsigned integer. So we want to make sure it's large enough so that we can have things, large values to print, either for a long time, or if it's incrementing, or if they're just big values. And this is going to be called value. And in here, it's going to be quite unique, because we cannot send an unsigned integer or any integers to this register. We have to first turn it into characters, right? In ASCII. And to do that, we're going to create a buffer array of size 12. And we're going to save the ASCII version of our value into this buffer. And to do that, we're going to do a conversion from unsigned long to ASCII. Okay. And then we're going to open it up. It's a function call. So we're going to pass the value. And that's the value we want to convert. This is the location we want to send it. And this is the base, or the radix of said value. So in this case, it's base 10, because, normal people usually want to count from 0 to 9. And so it's base 10. Unless your integers are solely like binary, you can really just make this 2. But we'll make it 10. Okay, so when that's done and it's converted it into a character or an ASCII, we'll just send this to the string. Okay, we'll send this to string, and it's going to pass buffer. That's it. So this will just send this to here, and then this will send it back to here. So we've successfully just created our UART.c, and let's actually create our header file for this C file. We're going to call it uart.h, and we're going to say if it's not defined, if this file is not defined specifically, then define it. And then at the end, just end the definition. And then in the middle here, we're just going to start copy and pasting the function calls that we had, the function definitions rather. We're going to go here, we're going to paste this here and remove the bracket at the end. You can keep this if you want, you don't have to. I'm going to go here and also include your standard library for integers, because you need it for this. I'm going to do the same thing for the other functions. So I'm going to grab this, go here, paste here, go here, paste this in here, go here, take this, paste it in here, and voila. Okay. And by the way, you don't actually have to have all these in here, but I like to have it as a visual. So now that that's implemented, we're going to save this file. We're going to also save the uart.c. We're going to go to the main, and up here, I'm going to include the file uart.h. And in our main, we're going to actually initialize it, right? It's called UART initialize. And don't forget, we have to actually pass a value. We have to pass a baud rate. And a common one is just 9600. Okay. So here we initialize that, and then we're going to go in our while loop. So the first thing I want to see is I want to see the amount of seconds passed whenever each blink occurs, right? So what I expect to see is 1000, 2000, 3000 milliseconds, right? Whenever it blinks, it turns on and off. So for that, I'm going to go in here. I'm going to write print string, open up the brackets, and write time. Okay. After that, I'm going to write print integer current time. Okay, so I'm going to print the current time, which is system time. And system time will be the time at which it will basically be reaching in this function. So it should be 1000, 2000, 3000. And then after that, we're going to print the string. But in this case, we just wanted to create a new line and place the cursor at the beginning of the line. So to do that, we have to do \r. So this will bring the cursor at the beginning of the line, and then \n to bring it to a new line. Okay. So that's that. So let's just upload this first, see if it compiles. Let's see if we didn't make a mistake. There you go. Success. And to open up the serial monitor, so I already opened it up. I'm going to actually open up a clean terminal so that you guys are following along. So I'm going to upload this again. So this is what it looks like. All right, success. Now, to see the serial monitor, you can either open up your Arduino IDE serial monitor or the one from Visual Studio. Here, I'm going to just open it up directly from VS Code by clicking this little plug, by the way. And when you open the plug and you hover over, it says serial monitor. So that's how you know that that's a serial monitor. And looking at the serial monitor, you see that there's values that are being printed. And look at that. Time, 1000, 2000, 3000. And now we're at 15,000, 17, 18, 19. Nice. So it's incrementing perfectly. And look at that. It's also incrementing exactly at 1000 milliseconds. So that's very nice. Okay. Now, you may, by the way, have used millis and did the same thing, but millis will also give you the same amount. But before I said, hey, millis gives you 1024. Well, when you do this function, you're still going to get 1000 because when you're doing a difference, you're subtracting that error. So you won't actually, you'll still see the same thing. Okay. So here we printed the time, the current time, and then print string. But I also want to print hello world when I press the button. So I'm going to go here and I'm going to print string hello world. And since it's a string by itself, I can add the \r, \n right away. And I'm going to upload this. It opens up the serial monitor again. We have the same incremental counter. And when I press the button, look at that. Hello world. That's pretty cool. I'm going to press it again. Hello world. So in this video, we were able to successfully create our own UART or serial print by actually manipulating registers, doing AND operations again, and we were able to see it right here. So I hope you enjoyed the video. I think this video might be one of the most important ones in the series because we'll be using these function calls quite a lot when we're doing debugging and just tests in general. So I hope you enjoyed the video. Comment down below what you think, like, subscribe, dislike, whatever you want. And I hope to see you guys in the next video. Take care.